Okay, so what follows is another video I recorded. I think this was like 5 years ago, 6 years ago at the Coast Guard Academy, where we continue on with the spreadsheet approach to doing piping system. But now I'm going to include a pump in there so we can do pump matching. And that's only a little bit of the video. The rest of the video shows where I am giving instruction on how to do a project that was assigned to that class, where I'm showing them if they want to use PowerPoint to draw the system out. So it might interest you if you're in my UHART fluid mechanics class, or maybe not. But I think you might get some benefit out of it as well, so I'm leaving that portion in. So without further ado.
Here's a quick video describing some of the things I talk about in class about trying to use the pump curves and the system curves that we've generated. So I will cancel out of this front screen right here, but continue recording. Okay, using Excel, let's see, I have to go back and pull the thing up. Maybe I should have had that all ready to go. Alright, so we generated a pump curve that looks something along these lines. And a system curve that looks something along these lines. What I want to do is try to show you how we can use this in Excel to match to a pump curve. And I could go about it in a number of different ways. Here's the way that I propose that we do it. If you have your pump curve like we have right here, this is just a sample pump curve I grabbed off the internet. I can go ahead and snag it off of a PDF. Right? It could be from any type of source here, but I think it's easier to do it as a PDF. And I'm just going to go ahead and paste it, Control V, into my Excel spreadsheet. All right. I'm going to send this picture. I'm going to right-click and then send it to the back. You'll notice that I put it right around where my graph was. I'm going to stretch this graph out. So whoops, I grabbed the wrong guy here. All right, so let me try to grab the graph. The graph doesn't want to be grabbed. Come on, there you go. All right. And I want it to be bigger than my graph. I might actually, let me zoom out a little bit. Okay. Now here's the trick right here. We're gonna click on the outside border here, right click it, and we'll format it. And for fill, we'll go no fill. Now while I still have this format box open, I'm gonna click on the inside as well, and I'll go no fill. So what I want to do is make my graph invisible so I could see the graph behind it. Now, before I go much further here, I'm going to change what my range is so that I could match what the range is behind it. So I will right-click that, and oops, I'm the wrong one. I want to get the axis. I want to format the axis, and if I look closely in the back, it goes up to what I believe to be 350. I might have to look at that again. So I'm going to go 350, and it counts by 50s. Right, so let's see. What I'm going to do, the idea here is I'm going to try to match up the graph right there. And I think I'm off by some, and I have gotten this to work the correct way. What I need to do is stretch this up a little bit, and it should be so that my small markers end up matching. So I don't quite like what the extent is on this one. I'm going to make it to 300 instead. 300, right? And I'm going to pull this down so it matches 300. And I'm going to do the same thing for the x-axis. it appears to me that it's a little tough to figure out what's going on to the off to the right. So I'm just going to make it to 640, and I notice my increments are 80. Okay, so I'm going to grab inside this graph, and I'm going to move it. So right there. Okay. And I think this shifted a little bit, so I'm going to get it lined up as best as I can. And move this down so it's the 300. Okay. I think I got that lined up. Well, maybe a little bit better. Right. Well, now once I have all those, I'll go ahead, because the graph has its own labels. I'll delete these. And I can go ahead and get rid of the numbers. They're not actually going to be gone. I'm just going to hide them. So I clicked onto the axis and hit none. I can click onto this x-axis well and go to the where it says axis labels. I go down to none. So now I have my curve superimposed on top of my system curve, superimposed on top of my pump curve. Now this one has a bunch of different pump diameters, impeller diameters that is. One year someone mistook this diameter for their pipe diameter. We can laugh at them and then make sure we never make the same mistake, because anyone could make that mistake. Anyway, yeah, so these are different impeller diameters for the same pump housing, and I'm going to change my system curve around here just a little bit, because let's say if I have like a 3-inch pipe instead of a 2-inch pipe, you could see, okay, that makes sense. Look, you could where now perhaps we had a system that with a 7-inch diameter impeller, and for the system that we're describing up here with the 3-inch pipe, it would operate at about 240 plus. Let's see where these increments are. This line in between here looks like, what did I say? There were 80, so it'll be 280 right here. So I'm going to guess maybe some of this, or 255 or something like that would be what that would be the gallons per minute that our pump would be operating at, which would be producing a head of just below 200 feet of head across the pump, right? So that's the matching part of this. Now, like maybe that's not the operating point we want. So what we could do is we could change to 3.5-inch, and of course we've set up our system here so that we could go ahead and make up to 500 gallons per minute right there of our range, so we could extend our curve that way. So like maybe that's not enough for us. Maybe we need like 400 gallons per minute. Well, we could see that our 7.5-inch diameter impeller is not going to do it for us, but our 8-inch diameter impeller will produce at least 400 gallons per minute. And the head level, the head is just going to be what the head is, by the way. It will produce that 120 psi at the discharge. And that's the deal here, right? So that's this curve is specific to the 120 psi at the discharge. Now, while I'm making this video, because this is fairly short, right, that we could make this description on how to use the impeller, I'll go ahead and talk a little bit about trying to use Microsoft PowerPoint, of all things, to make a decent looking drawing. Now, a template that I'm going to put up onto D2L will look like this. I'm going to go ahead and use like this generic looking ship thing instead. And I'll show you with some of the things that I've placed on here already. Now, I tried to make a drawing border type of thing, just so that we have something to go with, because we don't have a drafting program, or not everyone has the same drawing program. Let's use this Microsoft PowerPoint. And so as part of that, I made this outline, this outer thing, as if it is a group, right? So these are objects that I've grouped together. You could accidentally move them. I would recommend if you accidentally move them that you immediately hit undo. Otherwise, you're going to have some things to move around. But I put in little text boxes, so you can put in your different name in here and put in the date the thing is due, to get the team name, or I guess maybe this should be a fire main project or something along those lines. Name it what you think is appropriate. It could be the name of the fluid mechanics fire main project, something like that. And they go our group, and then you could put your different names in underneath it. It's always good to label stuff. I've also put a couple boxes in here that aren't a member of the border group, so that you could like move these things around. I also have this circle. It's very faint, but that'll help us decide. I placed it on top of there, trying to make it so that it was proportional to the 50-foot radius that each hose needs to go to. So I superimposed these after the fact. It's one of the last things I did. By the way, one technique for keeping the aspect ratio of something like, obviously I could make this thing any proportion I wanted to, but if I want to keep it the same, I can hold down Shift while I drag the thing, and it'll always stay the same size. It's little tricks like that that I'm trying to help you with, to try to make it make this a better looking presentation drawing. Okay, things I did for you here is I made a little globe valve, right? So we want to make sure we keep a list of symbols down at the bottom, and I put etc. because I wanted you to make some of your own. But I went ahead and made like a check valve and a globe valve. You might need a gate valve or some other kind of valve that's on their symbol list. The valve conventions of what they look like, they're not necessarily consistent between organizations, companies, or government agencies. I've found many different valve symbols out there, and haven't found one particular one that I think is like, hey, this is the one to always use. And there's a certain amount of discretion that goes into what's included and what isn't included on a piping diagram. Quite often these are called P&IDs, or piping and instrumentation diagrams. I used to call them schematics, but electrical people say that's their term, what have you. And there's always this kind of balance between making these simple diagrams, which aren't really supposed to tell you the arrangement of the system, only what's involved. There's always a balance between doing what is a P&ID and what's actually a layout drawing, which includes every fitting and all the different ways and the piping runs that go through there. We want to try to do this sort of blend in between. So let me start out with a couple things first. We're going to start with a C chest, and I'm just going to copy that and paste it onto the screen here. And I need a pump. I'll put this pump right here. Made a centrifugal pump. Isn't he nice? Nice little thing here. And I made these out of just like basic dimensions, and then I grouped them together. I'll show you how I did that in a second here. And by the way, I don't want you to just do simply what I've done here. I want you to make it even better. Okay, so I'm just trying to share some techniques to try to make a decent looking drawing with the scarce tools that we have. And for whatever reason, it does not want me to pick up this valve I just made here. Oh, okay. Well, here you go. Here's a what not to do. Okay, Control V. I'm just grabbing these and copying them, and it doesn't want me to do it for some reason. Come on. There you go. Okay. So I moved her up there. Now, let's say, I think for us, we have like a particular room where we want to place these things. This thing's driving me nuts. I think I need to zoom in a little bit more. Sometimes that helps to try to grab things and slide them around. I think it's just the end of the day and the thing's mad. Jerk. Come on. Why are you doing this? Computer's old, mouse is old, I'm old. Come on, jerk. Ugh. Undo. It's the end of the day. I want to go home. Alright. So I'm going to go ahead and just position these things roughly where I want them. All right, so just to give you an idea what these parts are, in case it isn't obvious to you. All right. This is a C chest over here, right? And this is a check valve. And this is a strainer, a duplex strainer. That means there's two strainers side by side with each other so that you can keep the thing operating, and you just shift over from one side to another. There's a big handle, and so like you can open up one of the strainers and actually remove the basket and get all the little fish and various things, wildlife and marine growth and so forth, stuff out of there. All right, now most of the time, for this type of arrangement here, we'd be treating the thing like it's at the outside of the ship, and I think I accidentally moved that so it was a little off kilter, and I need to zoom in here to be able to get the handle. You see this little handle? I want to turn this guy around. A lot of times for many installations, I've seen a convention where they make this first valve the same size, right? So I'm eyeballing it here, and maybe this valve's already too large anyway. We want to be able to fit everything in there. So there's some monkeying about that takes place. All right, so I put the valve right next to the sea chest here, and I'm going to take a pipe off of this thing. Now, what's nice is because I built this thing out of triangles and then grouped them together, it has these little attachment points. So I'm going to grab a hold of them, and I'm going to hold down my mouse key as I'm doing this. Now, if I've touched the thing, but I'm keeping the mouse key down, I can hold Shift, and I can make this thing, make this go as a straight line, which is kind of nice right there, right? And I kind of want that to be a thicker line. Now, I could right-click it and so forth, but here's a shortcut where I could just go ahead and say, that looks pretty good. Maybe I'll make it this thickness. Yeah, that looks about appropriate for what I want to do. Now, I could go ahead and put in some more. Let's see. I'll make the bend here because I'd like to go horizontally. So once again, I click on that, hold Shift down, and I'm going to move it to right here. Now I want this thing to be the same as this guy, so I'm just going to click on that guy, go to Format Painter over here, and because it's already selected, I can click right there, and I just made that the same. I'm going to go ahead and put my strainer, just drop it right on top. If I wanted to, and I think I accidentally moved this line a little bit, if I wanted to, I could bring him to front. Maybe. It doesn't really quite matter on this one. And I can go ahead and touch this guy and still hold down Shift and move that over. Like maybe I want to have my check valve right here. Quite often, actually, we want to have a check valve right after this on a marine system. I believe there's rules depending on deciding the order in which this first valve. Sometimes they'll call this a skin valve because it's the first one attached to the skin of the ship. So maybe I want to go ahead and put this in there. I could put these in this way right here, or I could put in a short run of pipe maybe. I could just make him in here, and of course he's not going to be exactly straight now, but he's going to be pretty close. And I could put in another bend. Hopefully this isn't all over the place. You can cut me some slack. I'm tired. He doesn't look quite right to me. a lot of times, many of the details that you want just to double check that everything just looks just right makes a huge difference. It's really an important engineering thing to make a detailed, good-looking drawing and convey your message, but also everything that you do is a reflection on who you are as an engineer. So if you can produce something that looks good, it makes you look good. And also, you'll be a boss pretty soon. And if you want good work out of your subordinates, you need to raise the bar and lead by example. So these are all good ideas to try to produce something that looks good. Now, this isn't always the tool that you'd use, but I'm doing the best with what we got. So here is where we've already made like our pump suction, like right along here. I might have even put an additional valve in there. It isn't necessarily that we do that, but I might do it. Now, I do probably want to have a valve on the outlet somewhere. I'm going to pass through a bulkhead here in a second, so I want to make a couple of modifications. I'll copy this, and maybe I'll explode it. While I'm holding the thing up, I'll go to group and ungroup these things. Okay, so now you can see that they're parts. And so as part of that, I will draw, as part of that, it's funny. Maybe I'll make this a gate valve now. Okay, so this is the symbol that I'll want to include. I'll want to include it down below and make a gate valve. I guess I'll go ahead and make it this dimension. It looks a little big to me. Also, I think it's adding a shadow in there. So maybe if I just click on this triangle and let's see, it's not going to let me do that, is it? Maybe, here we go. It's too close to it. Let me see. I'll move this guy over here and I'll use him. I'll format him. There you go. I got rid of that silly shadow. And now I'll click on top of these and I'll grab all of them and group them again. Okay, so now we have a gate valve, and I believe the requirements of this project is that there's a gate valve on each side. Maybe double check, and each side of a bulkhead penetration. And maybe I want to make a bulkhead penetration. Maybe that would look good to have a bulkhead penetration. Maybe these things are too close to each other. So what I'll do is I'll make a symbol for a bulkhead penetration. And I'll zoom in on that. I should have had a better plan about what I was going to include or what I wasn't going to include. I'm kind of ad-libbing it here. It's kind of dangerous, isn't it? Yeah, okay. I like that. I like the one without a shadow better. It's not hurting anything to have the piping as a shadow, but these little blocks, I don't think it does it much good. All right, so I'm going to make what I'm going to consider a bulkhead penetration, something along those lines right here. And I know it's a simple thing right here, but it'll help me to communicate what it is I want to communicate, and that is... let's see, what am I doing? Alright, so I'll move that guy right here, this guy right here, move that over. Yeah, I'm making a mess. All right, let me just draw the thing. Let me draw the thing out. Alright, I gotta get these aligned. By the way, something that you could do that's helpful is you could automatically align these things by grabbing two things and saying align and now middle. And now they'll be in line with each other, instead of having to do my what I'm doing right here, where I'm just sort of nudging it and kind of eyeballing it. And then once, of course, I made a little line, so make this right here. Alright, so that's not really great. I'm kind of like cramping the thing up a little bit too much. Alright, so And I want to try to get those as horizontal as possible. Anyway, so that's the idea there. And maybe I want to take, this bulkhead penetration and include him down as one of my symbols, or make sure I put the gate valve down as one of my symbols. But as part of what I'm going to do, what I would suggest as part of the project is you kind of make like sort of a main header for this thing. And of course there's penetrations at each of these places, so that you would want to include them in each spot. But you would want to like make some type of, let's say, a symbol. Let's say right here, and we'll call that, this will end up being a fire station right here. So maybe make a white fill here, and I'll make the line, maybe I'll make it black, it doesn't really matter. I might even add some text inside this box, where you can go in and edit text right here, right? And I'll just go FS for right now. I think my text is too small to actually show up, so while I'm inside the thing, yeah, I tried to make 29 font. So let's see, I bring this thing down, and I think it tried to make, for whatever reason, some kind of default is making the text white for some reason. Okay, so there you go. Yours won't necessarily do that. I don't know, maybe I accidentally made the template that way. But like maybe I want to make this thing and call it Fire Station 1. Something like that, FS1, right? And now I can draw out Fire Station 1, and I could put maybe, I think I'm not sure if it's a gate valve or a globe valve that we told you that we wanted to have, but you need to zoom in to be able to see this handle, right? So we move the handle here, and we set the thing in there, and then we can go. It would be nice, and maybe I should have done it. Let's see if I did do it. It'd be interesting if I did do it. Let's see. Be nice if these valves, let's say I'll bring this one to front. If I had made these valves, if I clicked inside there, and I'm just trying to click inside the group, it doesn't let me do that. So let me ungroup this. Ungroup. So I just grab one of them. I'll format the shape, and I could go a solid fill and just make it white on the inside. And I could make him white on the inside as well. Solid. And now I could, whoops, undo. I'll just grab just those guys again and group them. But now they will show up. I don't have to put a little thing on each side. I don't have to put a pipe on each side. And I can go ahead and make this thing one piece. And because I brought this thing to the front, by the way. If I had sent it to the back, it would have been in the back right there, but I can bring it to the front. I've thrown in a whole bunch of information all at once, and I'm not sure how useful it will be, but if you go back into this and look at it a little at a time, you'll maybe be able to pick up some hints as to how to approach the thing. Lastly, what I had said about this circle right here is my intention, or what I had done on mine, was to just draw sort of something, and I made sure that was proportional. I carefully measured the scale that was already inherent on the building. I think there's a scale down here that you can look at, and you can try to figure out what the size of everything is. And I made this thing proportional to my drawing. I made sure that it was it was proportional, so it ended up being 50 feet as radius, so that like if I had more than one station. Let's see, if I have more than one station, I go Control C. By the way, I could have blocked that before I do it. And so now when I copy that, and let's say that that's 50 feet, I could move this to the approximate center of where that is, and I could see where my overlap is of where these hoses could extend to. All right, so those are some ideas, things that you could do to try to make a professional, or as professional as possible, looking drawing. Oh yeah, one other thing. I've made these so that they're like 11 by 17 or thereabouts, approximately. When you go to print the thing, I highly recommend that you first print to a PDF. right? And that you set the printer properties to the correct paper size. Let's see, wherever they happen to be. I think is default settings, or you might need to move it so that you end up getting the correct, like I said, paper size. Yeah. So it's 11 by 17 landscape, and with print preview, you'll do a lot better to double check what were the adjustments you need to make, and then make a PDF out of this before you print it. A lot of times that's going to solve some printing problems. And then lastly, something I had meant to mention to you is, like, often I will see people having a hard time printing something like this out. Here's the method of doing it, okay, is to grab a hold of the region that you want printed, and go to page layout, and then go to print area, and then set print area. Okay. Now go to print, and once again, I would recommend make this into a PDF, right, first, and now go to preview. I think I have mine already set up, but what you can do is go to page right here and go to fit to one page, and then also in margins you could center vertically and horizontally. But yeah, the key thing is to fit to one page, and then to look at it and say, okay, try to look at it first and say, is that going to be sufficient for the clarity? Is this going to be too small or too big? But this will help to make your final product look a lot better, to send it out and make a well-sized and well-presented output. So those are the hints that I'm putting out there for you today, and I got to figure out how to turn this video off now that I've been running it, because somewhere in the background here it's running. What's going on here? Okay, so we go to add-ins and then we go to stop recording. There you go. That's it. So this has been a hastily made video. I hope it helps you on a couple levels. First, to get the curve and system matching together, to get that concept down, but also the mechanics of trying to use Excel and the system Excel spreadsheet that we put together to get that to work, and then also work in conjunction with the pump curves, and then also to make a good, neat looking diagram in Microsoft PowerPoint. Thank you very much.